Hey, Bryce here from Robotics Competition News. I'm here in the pit with 1369. Talk about some cool stuff with their winch. Here we have.
Hi, I'm Erin Pietatelli.
And I'm Ryan Ward.
Awesome. So the first thing I noticed when I was walking by you guys, I saw like a really interesting rope design. Can you tell me a little bit about that?
So our rope design is a simple paracord, and we have knots tied in at the bottom to hook onto our kind of comb design. And when we pull up, we notice that in the top, where this hooks onto the davit, our rope was getting kind of cut because of the swaying motion. So we added on the denim strip as reinforcement from a pair of old jeans. And it's been working fine ever since.
Yeah, I've seen a lot of teams like struggle with like standard ropes just getting like cut by the ends of the davit because they're kind of sharp at right angles. So that's like a really cool design, just like kind of like not strengthening, but just like protecting insulation from it. And this is like an old comb design for your intake?
Yes, this is the original design for our intake system or our climbing mechanism, and it's only about 4 inches wide. And we realized that it was taking a long time to line up to the rope and to climb, so we replaced it with an 11-inch one. So now it takes no time at all to climb, and then the climbing takes only about 2 to 3 seconds.
Okay, very cool. Yeah, I've seen like teams like struggle with like Velcro and other stuff, but just like a raw like comb, I think it's a lot more reliable in my opinion at least, because it's like always like the same. It's very consistent in how it picks up. So you said you guys went through a lot of like design like pivoting after your first competition. Can you tell me a little bit about that?
Definitely. So in our first competition, we actually had plans to shoot. We had a full hopper and a shooter, and we had full intentions to, but when we actually got into competition, we realized that we never found ourselves actually shooting at all. So when we got back from that competition, we thought, what would be an appropriate modular addition onto our robot? And we saw that the gear floor pickup was a big advantage to the teams that had it in the competition. So we decided to scrap the shooter and put on the gear floor pickup.
And then you had like an interesting method for. I know you said you had a PTO for your winch. How is that working for you guys?
So the PTO works really well because we have 6 sim motors for our drivetrain, which gives us a lot of torque, and we can use that same power onto our climber to lift our 150-pound robot.
Just less motors to add on.
That's
Same
right.
motors.
Absolutely.
Good.
I was going to say mathematically that robot can go up in a quarter of a second, but it'd be a little bit ridiculous.
What have you been seeing realistic like times in the fields?
We were able to slow it down to a comfortable 2 to 3 seconds. That way we can go up fast enough to where we don't have to worry about time management, but we're also quick and reliable.
And not going so fast that you can break the davit and get the FTAs mad.
One time we did climb in the last 5 seconds of the match and got our 50 points from that. We actually named our climber Mr. 50 because of its ability to get us 50 points every match.
That's awesome. Oh, man. Something else I noticed about your drivetrain just now. So you have like 2 Coulson wheels in the fronts and then Omnis in the back. Are you driving all 3 wheels on each side?
We have the 2 Omnis on the gear manipulator side that uses the load-in station because it helps us turn more quickly. And we were realizing that we weren't turning very quickly, so we replaced those ones with Omni wheels, and then we kept Coulson wheels for the other wheels.
So do you have a drop center or all the wheels in the same plane?
They're all the same.
Okay.
Yeah.
Very cool stuff. Thank you guys.
Thank you.